I want to demonstrate basically a neuron situation based on how, I mean, you can find it everywhere, and I'm going to post two examples from Ninja Nerd as well as the Anatomy Zone. So basically what happens is we have our neurons, which have an internal voltage which is negative. Usually the resting voltage is negative 70. And then based on whenever there's a synapses up here, right? So this would be like where our brain is. And we have a thought, a positive potential. You end up dropping the potential around these gates, right? And when it gets to threshold, which is negative 55 volts, then it opens up these channels, allowing for positive sodium ions to rush in. Now, what you'll see, the only reason why I'm showing you this is to correct for their understanding, the misunderstanding. They'll show you where these positive ions will just run their way down the path, and they'll usually just show it to you with a single, unipolar, just one to make it simpler. But we understand from just the fact that this is a plexus and it all divides up, that it does have to make these choices. And you'll see where even in the spine, and Ninja Nerd's he's the best resource, one of the best resources. Anatomy Zone is just like one of the best too. I started with Anatomy Zone, but they'll all show you the same thing. They'll show you where the sodium ions, basically anytime they show a gate open, they'll show positive, making its way to just arbitrary directions. Now, what that implies is that, like right now where my fingers are all just kind of in equilibrium, where they're gonna have the same basically resistance or potential. Either way, they're gonna show a situation like this where it's just arbitrarily making choices. What I'm saying is that it's not arbitrary, it's controlled by the autonomic nervous system. I think everyone that's not, even people that aren't doctors understand that they don't control their own heart or the contraction or the dilation of any arteries. And so now you have a fluid coming through and you have your autonomic nervous system, which can contract right here and dilate here. That's going to decrease the flow while increasing the flow here. That's going to overall have a lower potential drop here. So if you have two parallel resistors, right, and you know that one has a lower resistance and the other has a higher, there's just going to be far more current going in this direction. And so now what happens is you get to a point, like a termination point, whether or not it's where the muscle is, whether or not it's an actual joint, right? Or it's actually like the end of a finger, right? You can see where the blood builds up and then it turns white. That's where it comes to rest. When it comes to rest, because the fluid is the means at which you we're using, it's basically instead of a conductor, because a conductor would assume that we're pushing electrons through a crystal lattice like we're made out of a metal, or we know that that's not the case. So it's traveling in molecules or ions through the blood. And so now we're going to have a lower resistance, and then as it slows down, coming to a stop, the resistance is going to go from minimum to maximum. So we have a little example here, right? Just a little circuit example where we just give an example of 0.1 versus 2 ohms and a 30 millivolt drop. And how a 30 millivolt drop across those two, you can see it represented here. You're going to have, this is your current, and then times it by 2. This is going to be one potential drop, and then this is going to be the other. As you can see there, that's basically like 20 times the potential difference from making a left versus a right, or up or down, or any choice. And so a magnitude, and that's just an arbitrary value I chose. Obviously, when it comes to rest, it's going to be higher, and while it's moving, it could be even lower depending on the pulse. But just showing you how now, in a situation where you have just positives moving out in all directions, what really happens is that the autonomic nervous system has an artery moving down, sending blood to wherever it's going. It shuts off one, or contracts it like I showed, and then that's how at the end, wherever the muscle or wherever the action needs to occur, we have a much higher potential difference, and then that is how the signal makes its way. So the only reason why this mistake happened is because they didn't know electricity, and so they're just acquisitioning values. When you acquisition values, you get the highest potential difference there at the end. So you assume that it's just sending it through the peripheral nervous system. It's not sending any information through the peripheral nervous system. The peripheral nervous system is just a means in which it can acquisition the data based on you using your motor and sensory homunculi to model the world, and when you decide from a thought to an action. So now this gives some purpose also to the sensory and the motor homunculi. I'm not sure what they thought that was there for before. Whether they thought it was just a cool model representation, a doll, and then we go and we send signals to the body. The real use for the sensory and the motor homunculi, just like any simulation, is that's what you're actually acting in for us when you make decisions first, right? And so it's not like you have a computer with a model of a computer inside of it, right? The sensory and the motor homunculi are what we use to represent ourselves before we build this fake environment, right? Like the environment is real, but only with respect to like its physical, my physical response with it, right? The visual, all of these colors we're looking at, this is just a model of the world around us. It's not the act. We know that it's wavelengths. And so these wavelengths being represented as colors are part of the way in which we add simplicity to our model of the world, right? That's how we take these crystal lattices that are mostly empty air and represent them as solids. This is pretty definitive. I'm also going to post physics zone so that way you can see the numbers on there, how to do the calculations. I think they have a lot of calculators on there, so you can just type these values in, and then you'll see for yourself that, you know, basically from what they're saying, just to recap, that us having a synapsis, our brain up here making a high potential, that it's somehow sending its way down and just arbitrarily choosing a target muscle, a skeletal muscle. And I'm telling you that in reality, we're making a model of the world which is correlated between our consciousness, which what our consciousness does is a microcontroller, controller, and the autonomic nervous system, which is what the REM sleep, and I already explained that, but basically this is definitive proof.